Our parent function is the function f of x equals 1 over x. We are working specifically with f of x equals 2x plus 1 divided by x minus 3. So we're going to put this into graphing form. And to do that, we're going to call upon what you learned how to do in Unit 3. So in Unit 3, you learned how to do polynomial long division. The top always goes on the inside. The bottom goes on the outside. And just to refresh us, I'm going to make a little dotted line here to separate the columns. X times what gives you 2x? The answer is 2. X times what gives you 2x? The answer is 2. So it can go in the first column or the second column. And think of it as joining like terms. The number 2 is a constant. It's going to go in the last term. Now I'm going to multiply. 2 times x is 2x. 2 times negative 3 is negative 6. So first choose a number, then multiply. And now it's like we're going to subtract. And by subtracting, what we really do is we change the signs and everything in the second row. So this was positive, it becomes negative. This was negative, it becomes positive. Okay, we're going to add straight down. Positive 2x and negative 2x cancels out. That's our goal. And positive 1 and positive 6 is 7. So what does that mean? Well, this is going to help us in graphing as well. So this is f of x equals, remember this is our large number, and we pick this one up and it goes over the top of this one. So I'm going to put the large number in back. So this is our large number. This is the top of the fraction. This is the bottom of the fraction. I'm going to come up here and I write graphing form. F of x equals 7 over x minus 3 plus 2. Okay, so there's a few different ways. I want to point out both ways. They're in different forms. They're equivalent, but in different forms. So there's a few things we need to talk about. We need to talk about what an asymptote is. An asymptote is like a boundary line, and it's represented as a dotted line, and your actual function can never cross that line. It can approach it, but can never cross it. So let's talk about where do we actually come up with these. So your first one here, give me 1 second here. Your first one for this problem is this bottom part. And I'm going to just do this really lightly. I'm going to circle this, and I'm going to abbreviate VA for vertical asymptote, and I'm going to circle this, VA for vertical asymptote. So your denominator, remember these are equivalent forms, if you take your denominator and you set it equal to 0 and solve, you'd get x equals positive 3. This is your vertical asymptote. Take the highlighter that I asked you to have. Vertical, running up and down. Go to where x equals 3. Make a dotted line. Do not make a solid line. Make a dotted line running up and down. Okay? Good morning, April. All right, next up, we're going to figure out where do we get the vertical asymptote, sorry, the horizontal asymptote from. So your horizontal asymptote, if it's in this form, first of all, what is the degree of the top? That means what is the highest exponent on the top? And the answer is 1. What is the highest exponent on the bottom, or the degree? It is 1. As long as they have the same degree, when you're figuring out the horizontal asymptote, you get to divide the coefficients, the leading coefficients. 2 divided by 1 is 2. So the horizontal asymptote is y equals 2, because it's 2 over 1. Y equals 2. So that's when it's in this form. Now it's in the graphing form, it's the number that's hanging out in back. And you always include the symbol. So if this would have been a subtract 2, it would have been negative 2. In this case, it's positive. Again, they're the exact same things, just different form. So now go on to your graph. Go to y equals 2. and make a dotted line going across. So let's talk about what does this parent function look like. So on your calculator that I've asked you to have, please do second plus 712. Go to y equals. Type in 1 divided by x. 1 divided by x and graph it. So here's the parent function. When you look here, if we zoom this in just a little bit more, let's go from -5 to +5 and -5 to +5, just to see it a little bit better. So it's a curved shape. Do you see how as this goes upwards, it gets closer and closer to the y-axis? It will never touch the y-axis, it will never cross it. Likewise, as it goes to the right, it gets closer and closer to the x-axis. It'll never touch it and it'll never cross it. The same occurs down here. There's nothing in what we would have called quadrant 2 or quadrant 4 if we were thinking of this as 4 quadrants. If we were thinking of this as 4 quadrants, there's nothing in either one of these quadrants. Okay, so we're going to have some shape like this, okay? Some shape like this, so keep that in mind. Can it ever cross these, yes or no? No, Robert, I need you to pay attention, okay? All right, so the next thing we're going to do is we're going to come up to the very top and we're going to put in our asymptotes. So vertical asymptote was x equals 3. You cannot just write 3. X equals 3. Horizontal asymptote is y equals 2. There is no slant asymptote. You'll figure out how to do that on Thursday, but there is no slant asymptote with this problem. Now we're going to choose 2 numbers to the right and 2 numbers to the left. Good morning, Audrey. So here is x equals 3. We know it cannot cross that. We're going to do x equals 4 and x equals 5. So put a 4 here and a 5 here. Can I have all females plug 4 in? You have a choice here, females. You can plug in 4 here and get an answer, or plug in 4 here and get an answer. You're going to get the same thing, and you can give me a decimal answer. Can I have all males plug in 5? Do it using a calculator. Audrey, calculator as well. Thank you. So females, I'm going to choose to plug in 4 into this section. So I'm going to do 7 divided by, obviously 4 minus 3 is 1. Get the answer by pressing enter, and then plus 2. So I have 9. Males, I'm going to plug in a 5. So 7 divided by, well, 5 minus 3 is 2. But if you want to plug it in, make sure that it goes in parentheses. Add 2 to it, and you get 5.5. Okay, we're going to graph those. Go 4 and 9, please, and it may be off the graph, and that's okay. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 5.5. Okay, this gives us a general idea of how this is sloped. So it's going to go up here. You must include an arrow that it continues to go upward. And then it's going to come back down, getting closer and closer to our horizontal asymptote, but never touching or crossing it. We're going to do the same thing on the left-hand side. So I find the vertical asymptote, which happens to be 3 for this particular problem. I'm going to go 2 to the left. So now I'm going to go to -2 and to -1. Oh, sorry, +2, excuse me, and +1. Can I have all males please plug in 2? All females plug in 1. Again, you can use either equation. Go ahead. Rhonda, when you plug in 1, what did you get for an answer? Either equation. It's up to you, yeah? This is 2x plus 1 over 1x minus 3. This is 7 divided by x subtract 3 plus 2. So it's your choice. For instance, you can do 7 divided by 1 subtract 3, press enter, and then add 2 to it. So -1.5. Okay, males, what do you have for 2? You're getting -5? Okay, So I'm just going to clarify, see if that's right. Thank you. So 7 divided by 2 subtract 3 plus 2. I agree. Negative 5. Okay, let's graph them. Go positive 2 and down 5. 1, 2, 3, 4, 5. Go over 1 and down 1.5. Okay, so it gets closer and closer and comes up and gets closer and closer. All right, so some key points that we want to talk about here. So just for right now, I'm going to take a highlighter, just myself, you don't need to do this, and I'm going to highlight any of the boxes that we've done. Remember, for your upcoming test, you're not going to have to do all of these boxes, but they are here for us right now. Okay, so let's talk about what is a 0. So let's find the zeros. Does anybody see the place here that talks about zeros? Here we go, zeros. That means what are the x-intercepts? If you've forgotten that, you can write x-intercepts. Maybe 1, maybe more than 1. Generally there will just be 1. Generally there's just going to be 1 here. Okay, so for this particular problem, we want to know where does this exactly cross. And that would have helped us to draw an even more precise graph. You're always going to find the x-intercepts in this form. It comes from the numerator. Please set the numerator equal to 0 and solve. Okay? I'm going to give you right now 10 seconds. Set the numerator equal to 0 and solve. Go ahead. So the x-intercept occurs at x equals negative 0.5. So I'm going to come over here. Negative, so you can write negative 1/2 or negative 0.50. So negative 0.5, and I'm a little off there. I should have really found the 0 before I graphed it. Okay, I'm done with this box as well. So real zeros, okay, same thing here. So I can come over here and write that we have the x-intercept is negative 0.5 and 0. When you find a y-intercept, what is x equal to? Anybody? 0. When we find the y-intercept, x is equal to 0. So I'm going to write x equals 0 here. And choose either one of these forms and we're going to solve. Choose either one of these forms. So I think this form looks easiest. Remember, they're equivalent forms. So I'm going to write f of x equals, which is the same as y, 2x plus 1 over 1x minus 3. Again, y-intercept, good morning Gilbert, with the y-intercept x will equal 0. So 2 times 0 is 0. 1 times 0 is 0. 0 plus 1 divided by 0 minus 3. That means that the y-intercept occurs at negative 1/3. Negative 1/3. So I'm going to write it as an ordered pair. When x is 0, y is negative 1/3. Now I want to find that. 0 and negative 1/3 and make a dot. Okay, let's talk about the end behavior. So as we go to the right, okay, as we go to the right, does everybody see positive x here? As a reminder, I know we haven't done this in a few months. I'm going to put right underneath the positive infinity. As x goes to positive infinity, that means as it goes to the right. This arrow is going to get closer and closer to this line, but it'll never touch it. So what is it nearing as you go to the right? It's nearing a number. It's nearing the number y equals 2. As this goes to the right, it gets closer and closer to y equals 2. As this goes to the far left, to negative infinity, it's getting closer and closer to y equals 2. Cross those out, please. Oh, sorry, my fault. I asked you to keep it clean. That's my fault. Okay, so let's look back up here then. Going back here, domain. So let's look at the domain. So this arrow says it'll continue to go to the left and it's never ever going to stop. So all x values to the left, to negative infinity, never going to stop. Then it keeps coming here. There's only one place on this graph where the domain does not occur. Turn to your partner. What's the only place where we don't see the function touch this place, okay? Talk to your partner. Going to give you 5 seconds. Ready? Talking to your partner. Go. 5, 4, 3, 2, and 1. Laura, what do you think? You just looked awkwardly at each other? Oh, it's even terrible. Okay, Roger, what do you think? That line is right. Yep, that's good. Brian, what is that line? Define that line for me. Give me an equation. What's that line that going from left to right, it's never going to touch that line? Or give me the color of the line, Brian, to make it even easier. Okay, now blue is what we're going to come to in a little bit, but for domain, we're talking about going from left to right. The pink one, what is the equation for the pink? It is x equals 3. So everything except x equals 3. So the domain is all real numbers. We're going to put it in words, and then we're going to put it in interval notation. All real numbers except positive 3. So there's our words. Now let's put it into interval notation. So it comes from negative infinity. Remember, we cannot touch negative infinity, so I'm going to put a parenthesis. Comes from negative infinity, and it goes as far as 3. Does it touch 3? Does this touch 3, guys? So if it doesn't touch, do I do parenthesis or bracket? Nice job. And then it starts again at 3 again, but it's not touching it, and it goes to positive infinity. With your partner, I'd like you to try to do right now the range. Same concept. Please do the range. Yep. These are both going to be parentheses, not brackets, because it does not touch the 3. Okay, with your partner, do range, please. Need to see you talking. Go ahead. Blue Jay, focus. Rodrigo. Okay, the range. I'm going to start from the bottom. So if we follow this function, it comes up, it comes up, it comes up. It gets very close to the blue line. It never touches it. It's like it jumps over the blue line, and then it starts again, and it keeps going up. So the range occurs at all real numbers except the number 2. So all real numbers except 2. Now we're going to put it into interval notation. Interval notation is going to be from negative infinity up to 2, and from 2 to positive infinity. You're not going to be responsible for these 4 questions, so I'm going to stop right there.